Okay, so we are going to start the favorite chapters, of course, favorite information, pretty cool stuff that goes on. We're talking about erosion by wind and waves, and the reality is this: it's a process, and what I mean by that is erosion is a natural process for us, for the world, and erosion by wind and waves really does not only break stuff down, but it builds stuff up. And so it's a very, very important process of nature. However, we don't want it to happen when it causes problems for us. So our objectives are pretty simple. We're going to describe the way that wind erodes the land, and then we're going to compare the two types of deposits that take place as a result of wind. So the first thing I want to talk about is the fact that erosion is a natural process. It's a very natural process, but erosion happens. I lost something here. There we go. Back to what I was saying. Erosion is a natural process. And basically, the drier the soil, the more the effect that we see as a result of wind and wave and water, etc. And so the reality is, drier it is, the more it can carry. And so when we see when we see wind blowing particles, the real tiny particles are the ones that go the first. And so the faster the wind, the heavier the particle. And so if the wind dies down, it's not able to keep things up in the air, so to speak. And so it falls down. Now, we've talked about this process. It's called saltation. And basically what happens is, and the people who are watching this can't see this because I'm pulling up the whiteboard, but basically is we have wind blowing in the direction going this way, and what happens is as the wind's blowing, it picks the particle, but then as the wind speed decreases, the particle falls to the ground, and as the wind picks up again, it takes off again. This jumping, if you will, is called saltation. And so saltation speeds are great enough, it picks up particles. The heavier or the higher the speed of the wind, the bigger the particle that gets picked up. And so again, saltation is a series of jumps. This is called a haboob. And basically what it is this major dust storm associated with the front. And what's happening is wind is blowing down directly to the ground. I actually have a time lapse of a haboob. This is pretty cool, actually. I believe this is in Arizona. Yeah, Phoenix. And so what you have here is this apartment complex. The massive storm system is blowing down on the desert soil. As it does, it picks up the light particles, pushes it up in front of the front, and makes this huge, massive dust storm. And so you've seen it on TV when we talk about sandstorms in the desert. Same thing. This massive change in. It's not a tornado, but it is picking up all the dust and it's blowing it into another area. And when it gets here, it can get as dark as nighttime if it's the right type of a dust storm. And when it's done, all that dust that's in the air, it's got to go somewhere.
So like the Dust Bowl?
You're exactly right. So during the Dust Bowl, which is my next slide, what happened? What happened was we had over agriculture or over farming or not good farming practices taking place. We had a drought. And so during the Dust Bowl, some unbelievable amounts of soil were put into the wind and eroded away. And so it caused a problem. So the Dust Bowl was just this type of system. Deflation. All right. I had. So if I were to blow up a balloon, here we go. Okay. So sorry. Excuse me. What just happened to my balloon? It deflated. What was happening in the balloon? The air went out. Agreed?
Yeah.
And when it out, if I were to go and go, what happened to her hair? Blew away, right? So same thing. Sorry, I didn't have any coffee today, just so you know. So same thing. The sand in deflation, or the dirt, or the soil, or the material, it is being blown away. Why? The wind, as it blows through there, it's removing those small particles. And it creates areas that I want to show you, and I'll show you the images of it. It's pretty crazy. But what happens is it gets down to the bedrock. Bedrock, the base. And then when it does, it doesn't hold any soil. We call this desert pavement. I talked about glacial pavement last time. Same process, only different way of getting there. One's a glacier, the other's by blowing air. Right? Wind. Desert pavement. I'll show you pictures of that. Here is deflation. Right? What you have in this picture, basically all of the sand or soil or whatever is gone from here now. Here's the other thing that I want to point out to you. Deflation is an action. Desert pavement is a noun. Right? The act of deflation, all that soil and sand is gone. What's left is the object, desert pavement. A deflation hollow. Okay? If I take my balloon, blow it up, and then point it towards the sand, what will happen? The sand, it'll create a caved out area from where it blew the stuff away, right? Where the wind was the strongest. So that area, if we were to say Coach Ritter's head is hollow. By the way, I've been listening to some of you say this, so I know that you think that. What does it mean if my head is hollow?
There's nothing in there.
Nothing in there. That's right. So when we talk about a deflation hollow, it's an area that the material has been removed and it's hollow. There's nothing in there. Okay? So the next thing I want to talk to you about, let me go to a desert hollow. Hold on. So again, this is desert pavement. You know what I like about this picture? Look on the very edge. We see vegetation. The vegetation holds the dirt. The dirt then allows the vegetation to exist. The area where there was no vegetation, we had deflation take place, and now we have nothing but desert pavement. Love this picture. Here is a deflation hollow. Look how it's scalloped out of there, right? So the wind blew into this hole, basically, or this area, gets trapped there, and it blows all the sand out of this area. All right, ventifact. A ventifact. A ventifact is really cool, and I think it's amazing because what happens is, how many of you are familiar? How do they get paint off of a car? Let's say you're going to repair your car. You're like, oh, gotta fix my car. Yeah, can't. They sandblast it. Let me explain to you. We like to go to the beach. My family likes to go to the beach. We go to the beach a lot. We go to the beach all the time. It doesn't matter if it's the ocean. Doesn't matter if it's lake. Doesn't matter where it's at. We like to go to the beach. We always take our cooler. We got our soda pops in there. Pack a little lunch. We have a little umbrella. And we're hanging out at the beach. getting our tan on. I love peanut butter and jelly sandwiches.
Oh.
I never take peanut butter and jelly sandwiches to the beach. Why? Because when you start out with creamy peanut butter and it becomes chunky because the wind is picking up the sand, and as it does, it fills your peanut butter with sand, and then you get grit in your peanut butter. Not good, right? Well, Vintifax, when the air is picking up, how many of you have ever been to the beach and like that big dummy is in front of you, he's like doing his macho thing and he's walking through and the wind is blowing, and when he picks up his feet, the sand pelts you in the face.
Yep.
My dog, I love my dog. I love Lucy. She's such a good dog. My dog, when she goes running, she has such big paws that when she picks up her feet, dirt and sand flies up and hits you if you're behind her. I am never behind her when she's running. Now, mind you, I'm on a four-wheeler when she's running because I'm not running as fast as she is. But, yeah, so that sand that's flying in the air, it creates just like that sand blaster, and it blasts the rocks, and it polishes it, and it cuts through it. And so Vintifax, and I want to show you these. Here are Vintifax. These are two good examples of Vintifax. These rocks were just like this hole, and as they were, sand kept blowing through, blowing through, blowing through, blowing through, blowing through. And the areas that were lighter basically eroded away. So you can see a Vintifact is this rock that's been sandblasted and polished by sand. What goes up must come down. So when the wind picks up the sand, eventually it's got to go somewhere. So where does it go? It goes on the ground. Now here's the deal. Depending on what happens, depending on the speed of the wind, the direction of the wind, and depending on if there's any obstacles in the way, will determine what happens. So pretty cool. The larger the particle, the faster the wind has to blow. The smaller the particle, it doesn't have to blow so fast. So my first one, dunes. Now this isn't that movie that Sting made years and years ago that was really terrible. I'm talking about the thing that's out in the middle of an area, a sand dune. That's right. And what basically happens is we have a deposition of sand or soil, but mostly sand, where it starts to pile up. It's very easy. And to understand this, though, you have to understand the dynamics of a sand dune. People can't see this listening on their computer, but what happens is sand basically deposits. If the wind is blowing at an area where sand starts to deposit, and as it does, that sand has the windward side and the leeward side. The windward side and the leeward side. On the leeward side, we call this the slip face. Here's why. Wind is blowing this way. When it gets to this point, though, this area right below that, there's no wind. You're out of the wind. If you're in a windstorm and you hide behind the side of a building, you're not getting blown on. And so what happens is it deposits on the slip face. The slip face is the way away from wind. It's on the back side. And basically it creates this angle, and the dune grows out that way. So there are several different types of dunes. They are so easy to identify if you look at them. That's all you have to do. Just that simple. All right. So I'm gonna go back and forth here, just so you know. The Barchin dune, basically, it's a you guys know what parabolic is? Parabolic is this crescent shape, right? A parabolic mirror. It's the one that when you look in it, you're all of a sudden your belly looks like that big. You know what I'm talking about? So this crescent shape. All right, here we go. So I'll just show it to you. Here's a typical Barchin dune. So wind is coming from the left here, going to the right. It gets to this point where all of a sudden everything's hunky-dory. It's going around the outsides on both sides, but it gets to where the wind is blocked and it drops those particles down. And you see this scalloped look, this parabolic look. Only in this case, the curve is on the backside to the wind. Okay? This is a Barchin. Now, all of the dunes have names according to where they're at. The next one, parabolic. It's crescent shaped, but it's looking into the wind, not away from it. Okay? So let me show you on a picture here. This is a great picture right here. Look at letter D. Wind is coming this way on shore. These crescents are facing into the wind. Basically, it's this area, and I refer to it, it's kind of like a deflation, right? Deflation hollow, right? But what's happening is the parabolic is on the back, on the front side, not the back side. Okay, so that is parabolic dune. Transverse. Anybody know what a transverse gear is? What's a transverse gear? It's in a car. What's it do? It does, but which way is the transmission turning? So the transmission's turning like this, and these guys are doing this, right? It's a right angle, right? Transverse dune. So if we look at a transverse wave, here it is. Look, up, 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 right there. Transverse dune. And basically what's happening is you're having these layers, they deposit, it gets enough wind, it deposits, gets enough wind, it deposits. And so we see this. Very similar to waves on the ocean floor. If you've ever seen ripples in the sand, ripple marks. If we look at the big rock of mine that's now back at my house in the front yard that has ripple marks on it, very similar, transverse. Why? Those are the same. Doesn't matter if you're a liquid. Air is really a liquid anyway. It acts the same way physics-wise. Same thing. And then longitudinal. What's the word long? L-O-N-G. Should be longitudinal. Longitudinal, it's going parallel. Makes sense. So we have Barchin, which is crescent shape backward. Parabolic, crescent shape forward. Transverse, 90-degree angle. Longitudinal, parallel. What do you think? Everybody good here? I'll show you longitudinal. Longitudinal. Number B, letter B. Number B. Now, the one type of dune that I did not show you and put on here is my favorite type of dune, star dune. And if you've never seen a star dune, it's the most stinking coolest thing ever, 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 ever. All right, so star dune. Here is a star dune. And basically what is happening here is it tells me wind is coming from multiple directions. Here, 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 here. And basically this star dune has deflation and desert pavement in front of all the sides of it. And this star dune, and it doesn't, in this particular case, it's desert pavement. It doesn't have to have desert pavement. It could be such as this one, But again, these star dunes, how freaking cool is that? And the physics behind it, again, creating the areas, so amazing. And again, the air blowing into there. Star dune. Everybody good with star dune? Yeah. All right. This next word is pronounced loess. 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 Now, loess is also comes from a glacier. Loess also comes from sand and sand dunes and wind. All loess is a really, really, really fine, powdery sediment. Now, the reason why we are who we are, where we're at as farming communities, is because the glacial loess. Where'd that come from? Pulverized rock, rock flour. Rock flour goes into making the loess. Well, in here, the sand is pulverizing itself due to the wind. So we have sand blasting, sand, and we make this loess. In our area, extremely good for growing. Incredible, right? All right. So we're going to stop there. You guys have done a great job. I appreciate it. What we're going to do is assign 16-1, and the book questions go along with it. You guys, I appreciate you listening, and I hope you have a fabulous day.